welcome back to another video. Today's first question. So we have to prove that this actually works. So how do we do that? So technically, let me write this real quick. This would equal a to the power of m, and there are n of them. So if we write that out, there are n of them. And then, if we take it apart technically, it would be a times a. There are m in each one. One last one just to prove my point. And there are n AMs in total. So, each of these contain MAs, and in total there are n MAs, so that would equal a to the power of m. Moving on to question number 2. 1 over a, in parentheses, to the power of n equals 1 over a to the power of n. So how does this work? As I explained in an earlier video, a over b, just as an example, to the power of n would equal a to the power of n divided by b to the power of n. So if we apply the same thing, but this time a is 1, b is a. So if we apply the same thing to this, let me write this real quick. It would equal 1 to the power of n over a to the power of n. So then that would equal, since 1 to the power of n is still 1, no matter what it is, and the bottom would just stay a to the power of n. Moving on to question number 3. This one's a little bit different and slightly trickier, but it can still do. So negative n can also be written as 0 subtract n. And as I explained in a previous video, say this equation would equal a subtract n. And it also works the other way around, so you can flip it either way. So in this case, we need to put these numbers into this equation. So the a is still a, the m would be replaced with 0, and on the bottom, the n still n. And I don't know if you guys have heard of this or not before, but if any number, as long as it's not 0, to the power of 0, like a over 0 here, a can be any number except 0, it will always be 1. So we have a over 0 on the top, so that would be 1, and the bottom a over n. So these two match. Moving on to problem number 4. If n is even, then this would equal that. If n is odd, then this will equal that. So how does this work? When n is even, the first steps are basically the same. Negative a can be written as negative 1 times a. So negative a can equal negative 1 times a power of n, which would then equal, if you took it apart, negative 1 to the power of n times a to the power of n. And this is where the problem starts going into separate paths. When n is even, negative 1, and since even, you guys know this, if a negative times itself is the number of times its times by itself is even, then it becomes a positive. So it would be 1, because it's an even number when n is even, times an. So that would equal an, which matches our even description up here. But when n is odd, you guys also know this, that when a negative number times itself and the number of times it times itself is odd, it stays negative. So when it stays odd, when n is odd, it would stay -1 times a power of n, which would then equal -an, which also matches good old negative buddy up here. And I'll zoom out a little bit so you guys can see. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new. And I'll see you guys in the next one. Bye!